The density of a substance is the mass of a substance per unit volume. You can see over here on the right we have gas, liquid, and solid. Those beakers, the solid has the most mass in a given volume, so it's got the greatest density. Gases are the most spread out, so they have the least mass per given volume. So they have the lowest density. So generally, solids have the highest density, then liquids, then gases. There is one exception of water. Ice, which is the solid form of water, is actually less dense than its liquid, which is why ice floats. But that's a rare exception. Density is an intensive property, which means that it's always the same for a given substance. This is very important because if you determine the density of a substance, you can identify it. We can also find densities on reference tables online. So if I find the density of a substance to be around 9, there's a good chance that it may be copper. If the density always changed, then this information wouldn't be available on a table. So density is very important to help you identify what it may be. Go ahead and write the equation for density. So again, density is mass over volume. The mass is usually in grams, but it can be in any mass unit, such as kilograms, can technically be in tons or pounds, but our most common is going to be grams. Volume is usually in milliliters for liquids or centimeters cubed for solids. It's generally centimeters cubed for solids because the volume of a rectangle can be length times width times height. So that would be centimeters times centimeters times centimeters, which would give you centimeters cubed. An important thing to notice or recognize is 1 milliliter is equal to 1 centimeter cubed. So you can use them interchangeably. Finally, density has a unit on top and bottom because the units don't cancel. If mass was in grams and volume was in milliliters, they don't cancel, so the density would be in grams per milliliter. To find the volume of an irregular shaped object, we can't just do length times width times height. And I can't just pour it into a graduated cylinder like if it was a liquid. So to find the volume of an irregular shaped object, first I fill a graduated cylinder about halfway with water, which is what's happening here. Then you're going to record the volume of that graduated cylinder, or technically 7.0 milliliters. Next, I'm going to carefully drop the object into the graduated cylinder. Generally, I would tilt it and then slide it down. Record the new volume. So my new volume is now 9.0 milliliters. The difference in these two volumes must be due to the object that was dropped in there. So 9 minus 7, my object must have a volume of 2 milliliters. Water has a density of 1 gram per milliliter. Substances which are less dense than water will float. So here's water. These three substances are floating because their density is less than water. Substances that are more dense than water will sink. So all of these objects are sinking in relation to water because they're more dense. The more dense it is, the further on the bottom it is. You can have solids and you can have liquids in the mix. So my plastic is between the water and the oil. Go ahead and pause the video and figure out how these four substances would fill the graduated cylinder on the right. Figure out on substance A, would it be the top, second, third, fourth, and so on. So substance A is the most dense. Because substance A is the most dense, it should be at the bottom of the graduated cylinder. Substance C is the least dense, so substance C should be on the top. Substance D will float on B. So if D is floating on B, then that's how your graduation cylinder should be filled out on your paper. Go ahead and pause the video and try this one as well. So use the data table to figure out how the graduated cylinder will be filled with these four substances and water. Sometimes when you're given a problem, they give you extra information, like in this problem. In this problem, we didn't care about the boiling point, and we also really don't care about the description. The only thing that we need to know in order to rank these is which liquids have which densities. Well, substance Q has the largest density, and it is greater than the density of water. So Q should have been on the very bottom. These other three do not have a density greater than water, which means water has to be next. And these three, R, S, and T, will have to be above water. Of those, T is the most dense, then S, and R is the least dense. So that is how your density column should be filled out. Go ahead and pause the video and try this one on your own. Restart when you're done. They gave you numbers in this problem, but we didn't need any of those numbers. They said that you had a block of wood and then you cut it in half. They want to know the density of the two smaller blocks. Well, the blocks are all the same substance, so if you remember that density does not change as long as it's still the same phase, then you would have put that D, the density, has to be the same as the original. So let's pretend that we had a block and it was 6 grams and 18 centimeters cubed. Dividing those, that would give me a density of 0.33 grams per centimeters cubed. So that same block, if I cut it in half, now each block is going to be 3 grams, and the volume of each would be 9 centimeters cubed. 3 divided by 9 is still going to give me 0.33 grams per centimeter cubed for each of those. So when you cut the mass in half, you also cut the volume in half, so that ratio is always going to be the same. That's why the density did not change. So now let's look at some math problems. When you're solving the math problems, the first thing you want to do is label your different pieces. So it says the volume of this, so that's going to equal my V. You can either write it off to the side and say volume equals 35.7 centimeters cubed, but at bare minimum you need to say equals V in the problem. If it weighs 85 grams, then that must be my mass. And it says, what is the density? So density is equal to question mark. So I'm going to write the density equation. Always write your equation first, and then circle what you're looking for. In this problem, I'm looking for density. Because it's already set up for D equals, I don't have to rearrange. I'm just going to plug it in. So D equals, my mass is going to go on top. Make sure that you're putting your units, and my volume goes on bottom. It doesn't say what it wants its density in, so we can leave it as grams per centimeters cubed. Notice no units cancel, so I'm just going to divide. Dividing those out, I get all of that. This number had 2 sig figs. This one has 3 sig figs, which means I need 2 sig figs in my answer. That's 1, 2. So that 3 should round up, so it's going to be 2.4 grams per centimeter cubed. So they gave you 2 volumes, but those are the same volume, so that's my volume. They gave you 2 masses. I'm trying to find the density of this unknown liquid, which means I need to know the mass of the liquid. So my mass has to be the difference, because this is the empty graduated cylinder, and this is the graduated cylinder and the liquid. So 70 minus 26.5 gives me my mass. Now that I know my mass and my volume, go ahead and pause the video and calculate your density. You should have written the equation, circled what you were looking for, and rearranged if necessary. In this case, it wasn't necessary. So now I just say, well, my mass is 43.5. My volume was 45.6. I put my units, dividing that, and then looking, they both have 3 sig figs. So 1, 2, 3. That 3 should round up because there's a 9 there, and that's going to be grams per milliliter. Go ahead and find your variables for this one and rearrange. Restart once you've rearranged the equation. Don't move on past rearranging. So this one's a little bit different because we know the mass and the density, and we're looking for the volume. So just like before, we're going to write our equation. I'm going to circle what I'm looking for. Then I need to rearrange for volume. People mess up this one the most, so I'm going to go through all the steps real quick. So when looking for V, I'm going to have to always get rid of what's on the bottom. Anytime you have to rearrange, get rid of what's on the bottom. So I'm going to multiply both sides by V. So then I get dV equals M. I'm still looking for V. I need to get rid of D then, so divide by density. So finally, volume is equal to mass over density. Now I'm going to plug in my mass over my density. We're going to set this up dimensional analysis. Again, make sure that you're doing it this way and not just plugging it in algebraically, because we're using this throughout the year. And the main reason we're doing it this way is so we can make sure that our units cancel. So mass is on top, so we have our 200 grams. Density goes on bottom, but density has 2 units. Anytime something has 2 units, it needs its own set of boxes. So own set of boxes over here. D, or density, is on bottom, so that's where the number, so 19.3, and grams, or the mass, will go. Centimeters cubed goes on top. So you can think of the density like this. Wherever the D is, that's where this numerator is going to go. Opposite of the D is where the denominator goes. So notice D was on bottom, so that's why the 19.3 centimeters cubed on top. Now I'm going to cancel my units and make sure everything cancels. Notice grams is on top, grams is on bottom. Had I messed up my algebra, then these units wouldn't have canceled out. So it's a way of double checking your algebra. They want the volume in centimeters cubed, so I'm good. I just divide those two. And I need 3 sig figs. Both of them have 3 sig figs. That 3 is going to round up. So you should get 10.4. That's our units, centimeters cubed. There's no reason to guess on what your units are. It's whatever's left. Go ahead and pause the video and solve this one to get your grams. Restart when you have your grams. So in this problem, we knew our density and we know our volume. So density is equal to our mass over volume. We're looking for mass. So just like before, always get rid of what's on the bottom first. In this case, I'm looking for mass. So our mass is equal to D times V. So we're going to plug our density in first. So 13.6 grams. There's my line, and there's my milliliter. Anytime you see this slash, that slash is going to be this line here. We never put slash milliliters. Next, I'm going to put my volume. My volume needs to go on top because they're next to each other. They should be being multiplied. So 355.0 milliliters. Now I can cancel my units. Milliliters cancel with milliliters, and I'm left with grams. But the problem wants kilograms. So always double check what they want their unit in. We need one more step. Just like when we did our metric conversions, grams is on top, so grams must go on bottom. And I'm converting to kilograms. Kilo is bigger than grams, so I put my 1 with kilo, and 1,000 grams are in a kilogram. Cancel my units, and I have kilograms. Now that I have the unit I want, I can plug it into the calculator. I'm going to multiply on the top, and I'm going to divide going top to bottom. So we get 4.828 kilograms. We wanted 4 sig figs. This is density. We're not going to look at density for sig figs because we didn't measure that amount. That was a given quantity. The only one that we measured was the milliliters. So only look at your mass or volume when calculating for sig figs. So on this problem, we're looking for our density. They gave us our mass, and they didn't give us our volume, but we know that volume is length times width times height. And they gave us all our dimensions. So we don't need to rearrange. My mass is 1,500 grams. And for my volume, I can technically plug all those in off to the side, or I can just plug them in here. So 3.4 centimeters, 1.2 centimeters, and 1.7 centimeters. I don't have to have anything on top. So my volume, I used length times width times height. And so I just plugged in that equation. The advantage of doing it this way is if one of these was in millimeters, then I could just keep going and say, oh, well, let me convert my centimeters to meters or so on and get them all in the correct unit. But in this case, I'm done. So plugging this in the calculator, people struggle with this one. So let's plug this into the Google calculator. So when plugging it into the calculator, when you have more than one thing on the denominator, we're going to hit 1,500. Then divided by 3.4. Then divided by, we're going to keep dividing, 1.2. Divided by 1.7. So I get 216.26. I had 2 sig figs on everything, so I need 2 sig figs here. So that's 2, that 1 turns into a 2, and remember that we need a placeholder 0. All numbers that are getting dropped until we get to the decimal need to turn into zeros. So 220, and that's grams per centimeter cubed, because centimeter times centimeter times centimeter gives me centimeters cubed. Go ahead and solve this one on your own. Restart when you have your final answer. When doing this problem, you're going to want to break it up, solve for volume first, and then plug it into your dimensional analysis. So in this case, we're looking for density. They gave you your mass, and volume was by volume displacement. So we had 8 milliliters minus 2 milliliters. So the object must be 6 milliliters. Now I can plug it in. I know my mass goes on top. I know my volume goes on bottom with units. Nothing cancels. So dividing those, I get this. And I want 2 sig figs. So that 1 is going to round up, giving me 4.2 grams per milliliter. Go ahead and pause the video and solve this last one on your own. Restart when you're done. So just like before, we know our density and we know our mass. We're looking for volume. So rearranging like we did earlier, we get mass over density. We get that by multiplying by volume and then dividing by density. So I plug my mass in on top. My density goes on bottom. My density always gets its own set of boxes. But notice on this one, my units don't cancel out because I've got centigrams and grams. So I'm going to have to do one more set of converting. I need to get rid of grams, so it's got to go on top. And centigrams has to go on bottom, so they cancel. Of those two, grams is bigger, so it gets the 1. And there's 100 for centi for every gram. Make sure my units cancel and that I've placed everything correctly. I'm left with centimeters cubed, which is what I wanted. So now I just plug it into the calculator. The other place people are messing up is again plugging it into the calculator. So plugging that in, you should have 8.08. So 8.08 times 10 to the third. So remember, I'm going to use the exponent and then 3. Then I'm going to hit divided by. So there's my divide by, 8.05. Then I'm going to hit divided by 100. So I get 10.037. I don't look at density, I look at this one. There's 3 sig figs. That 3 doesn't round it up, so my final answer is 10.0 centimeters cubed.